Discontinuities are important in determining the stability of rock slopes. They can be distinguished by its geometric properties such as direction and orientation. Through the conventional method, compass has been used widely to measure discontinuities' direction and orientation. However, this method requires longer time to collect and analyze the data. With the advent of technology development, the discontinuities of a rock slope can be measured in more convenient way by using Terrestrial laser scanner TLS. The previous rock slope failure at NKVE Highway at Bukit Lanjan in 2003 negatively impacted our socio-economy. As for the UPNM campus, a road infrastructure constructed on hilly rock terrain at Bukit Gemilang is needed to be evaluated its stability, as no other study was found in the literature. This study evaluated the stability of Bukit Gemilang rock slope located on the UPNM campus and analysed risk of rockfall as well as providing possible remedial measure for future development. The study carried out based on the following objectives. First, to determine the discontinuities orientation of Bukit Gemilang rock slope using conventional method. Second, to compare the accuracy of data collected using conventional method and terrestrial laser scanner TLS. Third, to determine the stability of Bukit Gemilang rock slope using stereographic projection mapping, for example, rock science deep software. The significance of this research is to evaluate risk of rockfall, potential failure mechanism as well as to provide possible remedial measure of Bukit Gemilang rock slope. Suggestion can be made by installing rock anchor, wire mesh and dowel to protect the risky areas. The resulting outcome will be significantly useful for future development planning. Here are the methodology that had been carried out during this study. UPNM campus located inside Sungai Besi Military Camp, approximately 12 km south of Kuala Lumpur. The bedrock of Sungai Besi is composed of granite rock which consists of medium to coarse grained muscovite. The rock slope section has 70 meter width and 5 meter high. During conventional method, breadth-out compass were used to measure the discontinuities data, deep angle and deep direction on the rock slope surface. Next, working measure tape were used to measure the distance of each deep angle and deep direction. In order to carry out TLS method, 3 points were selected for setting up the TLS in front of the rock slope. Next, measure discontinuities deep angle using TrueView software, which is included in TLS analysis package at similar point as conventional method to obtain comparable result. Then, rock science deep software were used to determine possible rock slope failure by using Stereonet method. In conventional method, a total of 110 measurements that have discontinuities direction and orientation were measured and analysed manually. In TLS method, each predominant discontinuity plane of Bukit Gemilang is measured using TLS. Figure 7 shows the overview of outcrop at Bukit Gemilang through Leica TrueView software. The differences between discontinuities data measurement through conventional and TLS were tabulated in Table 1. Analyze the accuracy of data collected by using t-test. The p-value for two-tail analysis is 0.42, which is larger than 0.05, indicating no significant difference between conventional and TLS data. The test should fail to reject H-null. Both methods have similar values and indicating acceptable accuracy. Identify potential failure through rock science deep software. Figure 9a, planar failure Stereonet. The discontinuities joint F2 plane are oriented slightly parallel with the slope face, and it shows that potential planar failure occur is very low with percentage of 16.16%. Figure 9b, wedge failure Stereonet. The discontinuities joint F3 plane intersecting with discontinuities F4 plane, but does not lean on the potential failure. The potential wedge failure is 7.84%. Figure 9c, toppling failure Stereonet. The discontinuities join F1 plane very slightly oppose the slope face direction, and it considered very low to toppling failure occur with percentage of 4.04%. In conclusion, obtaining the discontinuities of rock using TLS are more efficient in terms of time and effort compared to the conventional method. Apart of that, TLS reduces risk and hazard imposed on the researchers during data collection. It is also more convenient to obtain data at the inaccessible location, such as on high and steep slope. The rock science dip, a Stereonet analysis showed that Bukit Gemilang is considered stable. Even though the slope has low risk, the potential of planar wedge and toppling failure might be occur due to weathering effect. Therefore, double bar and wire mesh installation are recommended at certain locations to prevent risk hazard to road user and nearby structure.